Hello ladies, it's Mr. O'Sullivan. Today you're going to be doing an edPuzzle assignment on linear function applications extended. So we did word problems yesterday. We're doing a second day of real world situations where we can use linear functions to apply them. So today's learning target is I can apply my knowledge of linear functions by examining a real world situation. So the first example we're going to look at is about a girl named Kayla and how she charges $15 for every 2 hours that she babysits her siblings. So the first question I'm going to ask you is, what's the important information in there? Well, we're in a math class, so we think numbers are pretty important. So we know that Kayla charges $15 for every 2 hours. So we're not going to do part A yet. We're going to actually do part B first. It says fill out the table for the amount that, not Maria, Kayla makes as she babysits. So for instance, for 2 hours, she makes $15. For 4 hours, she makes another $15. So 15 plus 15 is 30. So if I look, I'm going up by 2 for my h's, or my x values. And I'm going up by 15 for my y values, or my money. So 30 plus 15 is 45. So for 6 hours of work, Kayla has made $45. I can add another 15. For 8 hours of work, she has made 60. For 10 hours of work, she has made 75. And then last but not least, for 12 hours of work, which sounds pretty long, she has made $90. So the question I asked, though, for part A, how much would she charge for 5 hours? Well, if you look, we actually don't see a 5 in our table. It should be in between our 4 and our 6. So what I can do is, I can actually just use a little trick. So Kayla charges $15 for every 2 hours. So if I want to find out how much she's charging per hour, I can just do 15 divided by 2. Which will give me 7.5. So I know that Kayla is charging 7.5 or $7.50 per hour. So if I want to find out how much she charges for 5 hours, I just have to do 750 times 5. 750 times 5 is 37.5 or $37.50. So I can say that for 5 hours of work, Kayla charges $37.50. We did our table. Now we're going to do part C, where we graph our relationship. When we're going to graph our relationship, we always make sure our x-axis is time and our y-axis is our dependent variable. So in this case, money. So I'm going to do hours here. And I'm going to make every box 1. So I'm going to go out by 2s. So this is 1, then 2, but I'm not going to write my 1 because it's going to be messy. 4, 6, 8, 10, 12, 14. Now what I'm going to do is I'm going to make every 2 boxes 15, or every box worth 750. So 15, 30, 45, 60, 75, 90, and 105. What we want to do is we forgot to label our y-axis, so I'm going to label our y-axis. I'm going to do that in green for the amount of money made, or amount of money earned. So the amount of money earned. And if we look at the point 2, I get 15. So I'm going to plot that as a point, so 215. I also get 430, 645, 860, 1075, and 1290. I want, I can also plot 14, 105, because I know that's going to be on my line also. And then I can just draw a line going through those points. But here's the issue. If she's not working any hours, she's not making any money, so I should also be plotting the point 0, 0. I will now have a straight line going through those points. And that's my graph. Part D says, write a function to relate the amount Maria earns, A, to the number of hours she worked, H. Well, this whole unit's about linear functions, so before we even go into that A and H nonsense, I'm going to first write down y equals mx plus b, where m is our slope, or our rate of change, and b is our y-intercept, or our start point. So if I look, I actually know what my slope is. My slope is 7.50. The reason why I know it's 7.50 is because, look, I found out in the first question that she's charging $7.50 per hour. Whatever I'm charging per hour is what my slope is. So I know my slope is $7.50. And my y-intercept is 0, because if she's not working any amount of time, then she's not making any money. So when I write my equation, I can say y equals 7.50x plus 0, or I can just write y equals 7.50x. No need to put the plus 0. But here's the issue. I want it to be written in the form A to the number of hours she worked, H. Remember, H is time. This is your X value, which means by default, A has to be your Y value. So everywhere I see a Y, I'm going to put A, and everywhere I see an H, I'm going to put X. I mean, everywhere I see an X, I'm going to put H. So I have A equals 7.50H, and that's your equation. Now, part E says, what is the y-intercept? Well, we said our y-intercept before was 0, 0. So in this case, our y-intercept is just going to be 0. Now, what exactly does that mean? It simply means that if she doesn't work, she doesn't make any money. So like for 0 hours worked, she's going to make $0. Our slope, we said before, was 7.50. The slope is her rate, or the amount of money she's charging per hour. So in this situation, our slope of 7.50 means that she is charging $7.50 per hour of service. So if she works 1 hour, she makes $7.50. If she works 2 hours, she makes $15, and then so forth. Question number 2. Lachey has $450 in her savings account at the beginning of the year. She places money in the account at the rate of $5 per week. We want to model the amount of money she has in savings S as a function of the number of weeks she's been saving W. She will save money for exactly 1 year. So let's underline or highlight our key information. So we know she has $450 at the beginning of the year. Since it's at the beginning of the year, that's how much she's starting with. So I can tell you right now that my y-intercept is 450. Because she starts with this amount. She places money in the account at the rate of $5 per week. Whenever I see that word rate, that's a way of saying that this is your slope. So what I can say about this is, my slope is 5. And we want to model the amount in savings S as a function of the number of weeks she has been saving W. She will save money for exactly 1 year. So remember, time is always your X value. So in this case, W will be where I put my, W will replace my X, and S will replace my Y. So that's what we're going to do at the very end. Part A says write the function. So remember, we know Y equals mx plus b. Where m is our slope, or our rate. The reason why I say rate is because if you look in the question, it says rate, and b is our y-intercept, or how much we start with, or our start point. So if I look at this question, we said our slope was 5 and our y-intercept was 450. So when I put this into my equation, I can get my equation to be y equals 5x plus 450. What I now want to do, though, is I want to put that s and w in here. So remember, x is w, or w is x, and I will put an s where y is. So my equation will be s equals 5w plus 450. And that's your final answer. Now, what kind of numbers would make sense for the domain? That's like a critical thinking question. So when we talk about the domain, we are talking about our x values. So basically, when I talk about what numbers make sense, I mean, what numbers can I actually plug into this function? Well, if we look back at the question, Lachey is depositing money in the account at a rate of $5 per week. She's not depositing it after a certain amount of hours. She's depositing at the end of each week. So she's depositing it 1 week, 2 weeks, 3 weeks, 4 weeks, and so forth. So when we think about this, we wouldn't want to use real numbers. We wouldn't want to use rational numbers. We wouldn't want to use integers. We would want to use the natural numbers, or our counting numbers. So 1, 2, 3, 4, 5, 6, and so forth. So we would want to use our natural numbers because those are like the days of the amount of weeks. So like week 1, week 2, week 3, and so forth. So like those are the things we're talking about, the natural numbers, 1, 2, 3, 4, 5, 6, and so forth. Your y-intercept. If we look back in the question, we said our y-intercept was 450. So I can say my y-intercept is 450. And what that means is our y-intercept is our start point, or where we cross the y-axis. So we can say that 450 is how much Lachey started with in the bank. What would the range of this function be? Ooh, this is a good question. Well, if you think about it, she is saving money for exactly 1 year. How many weeks are in a year? There should be 52 weeks in 1 year. So what I want to do is I actually want to find out what my highest y value is. So I'm going to take my equation, s equals 5w plus 450, and plug in a 52 for w. That'll tell me how much money Lachey has in the account after 52 weeks. So s equals 5 times 52 plus 450. 5 times 52 plus 450 is going to be 710, which means that after 52 weeks, Lachey will have $710 into her account. But she started with 450, so I can say my range, which are my y values, well, my lowest is 450, my highest is 710, And then this is how I would write it in inequality notation. That's my range. I can also write it in interval notation by using brackets. So I can use 450, 710. And that's your final answer. And again, these are just linear function applications. You're not always going to be asked these exact questions. You could be asked similar ones, you could be asked a little different ones, but overall they're the same level of difficulty. If you have any questions, please email myself, Ms. Townsend, or Ms. Jimenez. And today you're just working on this edPuzzle assignment and you're finishing yesterday's Delta Math, which is just more linear function applications. Have a great day, ladies.